All right, welcome to another video on Unit 2, Exploring Two-Variable Data. In this video, we're going to focus on Topic 2.7, Residuals. Now, we're going to pick up literally right where we left off in our previous videos. And in those previous videos, we ended with talking about a linear regression model, which is y hat equals a plus bx. Remember, a linear regression model is used to take a given explanatory variable, x, and make a prediction for the y variable, or the response. All right, so let's remember the last problem we looked at. We were looking at the mileage and price of Ford F-150 trucks. And we looked at 16 trucks, and there's all the data on the left side. And we made a scatter plot, and we drew our linear regression model, our line of best fit, as you used to call it, through our data, and then we gave you the equation of that data. So what we now want to do is we're going to use this exact same problem, but we're going to piggyback into this new topic of what's a residual. Well, they're actually really important. So here's the deal. When we use a linear regression model to make a prediction for the response variable with a given explanatory variable, we most likely are going to be off a little bit, right? I mean, it's just a model. It's not perfect. So if you recall, one of our actual trucks had 75,678 miles on it, and it had a sale price of $28,986. That actual truck, if you recall, is right here somewhere. Huh? Where's it at? Oh, right here. This one right here. 75,678 miles and a sale price of $28,986. So here's the deal. If we used our linear model to predict the cost of a truck with 75,678 miles on it, we actually get a predicted price of $25,929.05. And just to prove that to you, here's all my work, right? I started off with the equation right here. Y hat equals 38,257 minus 0.1629 times x. And I plugged in the actual mileage of 75,678. I multiplied it, and then I took the 38,257, I subtracted, and I got our predicted price. But the point I'm trying to make here is that that predicted price was not the same as the actual price. The actual price was just shy of $29,000, and the predicted price was $25,929.05. So needless to say, our prediction with the model was off a little bit from what the actual price was. We call how much we're off by the residual value. So if I take the actual price of the truck, the actual Y value, the actual value from my data, and I subtract the predicted value that I got from my regression model, what you get is how much we were off by. And we call that value the residual value. It's how much we're off by. So for this particular truck, my residual was $3,056.95, which means that the actual price was $3,000 more than the predicted. The actual value was above the predicted, or I could look at it the other way around and say that the predicted value was less than or below the actual value. All right, so now that you kind of have a feeling for what a residual is, let's kind of put an actual definition on it. The residual is the difference between the actual Y value and the predicted Y value. We call these the vertical errors. I'll explain a little bit more in a moment what a vertical error, what I mean by that. But to find a residual value, it's literally as simple as taking the actual Y minus the predicted Y. All right, so where do you get the actual Y from? A lot of kids ask that. Where do I get the actual Y from? You get it from your data. So you got to look at your data to find the actual Y. Where do you get the predicted Y from? That comes from your regression model. That comes from using Y hat equals A plus BX. That's where you get Y hat from. That's where you get your prediction from. Now, every single value, every single data value on a scatter plot has its own residual value. Every value is either going to be a little bit above the prediction or every value is going to be a little bit below the prediction. So it's simply how far off a prediction is from what actually occurred. All right, so let's take a look at a graph, right? This is the actual graph of our scatter plot. All the blue dots are the actual values, and the red line is a graphical representation of my linear regression model. So you can actually see the residuals. The residual is the distance, vertical distance, that's why it's called a vertical error, between the actual point and the predicted point. So the prediction for this particular value of around $25,000, or I'm sorry, that's miles. So the prediction for 25,000 miles, the prediction was a little bit below the actual. So you could literally put like little vertical lines here. Some predictions are a little bit bigger, some predictions a little bit smaller. This one's really small, can barely see it. And every single dot has a residual. Think, again, like I said, vertical errors. It's the vertical distance between the actual point and the predicted. So any of the dots above the line are going to be positive residuals because the actual blue dot minus the predicted red line is going to be a positive. But if I do the actual blue for this one, since it's below the line, it's going to have a negative residual. So you'll notice that some residuals like this one right here are very, very small, and this one as well. Some residuals are a little bit bigger, like these two right here or this one right here. And some residuals are kind of like medium, like this one's kind of medium, this one's kind of medium. So you get the point. So not only can you find residuals using the very simple formula, actual y minus predicted y, but you can actually literally see the residuals in a scatter plot. All right, so what I did here in this particular chart is I actually went and found all the residuals for you. So here were all of the miles driven, and here were all of the actual prices of all 16 trucks, and then I found the residuals. So again, how did I find the residuals? Well, I took the formula y hat equals a plus bx. I used our formula, and I plugged in the miles driven for x, and I got a bunch of predictions. And then to get the actual residual, I took the actual price and minus the predicted price. So what I want you to notice is, what do we notice when we look at all of these residuals? Well, first off, I noticed that some are positive, like this one, this one, this one, this one, this one. Some are positive. Here's another positive. Remember, positive means that the actual value is higher than predicted. And some values are negative, like these first three were all negative. Here's another negative. Here's another negative. A couple down here, they're negative. And a negative residual means that the actual value was below the predicted value. So the prediction was higher than the actual, right? Also notice that some residuals are kind of small. Like right here, this residual is only off by about $458. That's actually pretty good when you're predicting the price of a car. Even this residual right here, only off by about $1,100. Again, that's a pretty small residual. Other residuals were quite large. Look at this residual. For crying out loud, I was off by $8,000, $8,600. We were off by. Our prediction was way off from what really happened. Here's another negative that's really large, negative 8,000. So the actual price was well under what we predicted. So that's just kind of what happens, right? When you're dealing with residuals, some are naturally going to be positive, some are naturally going to be negative, some are naturally going to be small, and some are naturally going to be large. That's actually a really good thing that we're going to talk about here shortly. Now, the one last thing I want to emphasize is that if you were adding up all of your residuals, if you were to add up all the residuals, you should get a sum of 0. Now, I'll be honest, if you actually pause this video and add up all these values, you don't get 0, but you get something fairly close to 0. The reason why you don't get exactly 0 is because all these numbers are rounded a little bit, right? So as you are rounding throughout the whole problem, when you have all that slight rounding together, you're not going to get exactly 0. But theoretically, all of your residuals, if found perfectly, should add up to 0, again, because of the balance between positive and negative and large and small. All right, so one more thing that we could do with a residual is we could make a plot of the residuals. And this is actually pretty cool, a little bit interesting, and some kids struggle to understand this, but I'll do my best to explain it. So a residual plot is literally a plot of all the residual values. So instead of the y-axis being the actual price, right, a scatter plot, the y-axis is the actual prices. Here, the y-axis is the residual values. So my x-axis is still the miles driven. It's still the explanatory variable, how many miles are on that truck. But instead of the scatter plot showing the corresponding prices of those trucks, it shows the corresponding residuals of those trucks. Now, and this is just another way to visually see that a lot of your residuals are going to be positive. Anything positive is going to be up here above 0. So all of these residuals up here are positive. And then there's also going to be a fair amount of negative residuals. All of the residuals down here are negative. There's the negative values there. And 0 is right smack in the dab in the middle. And the other thing we could visually see, some residual plot, is that some residuals are very small. Other residuals are quite large. And here's another fairly large residual. And then you have medium residuals, right? So just like I said, right, I'm trying to emphasize what the residuals are showing you. Some are going to be positive because the actuals were above predicted. Some are negative because the actuals are below predicted. Some are big, some are small, some are going to be close, some are going to be a little bit further away. But that's all a good thing. That's all a really, really good thing. So a residual plot simply gives you a feel for what those residuals look like. Now, an important fact, and I've been slowly trying to get this sunken in, but a really important fact is that a residual plot that shows nothing but randomness is exactly what we want to see. Going back to this residual plot right here, I like the fact that I see a whole bunch of nothing. I like the fact that the dots are all scattered about. There is no pattern. I don't see a line. I don't see a giant curve or parabola. This is a good thing, right? A random residual plot is evidence that a linear form is the association between the two variables. And it is evidence that using a linear regression model is very appropriate. Now, why is that? Well, I mean, let's just go back to our scatter plot for a second, right? Let me go ahead and erase all of the little marks I put here, right? I drew all those residuals. Let me erase all those for a second. Now, remember, a good line is a line that goes through your data. And when you go through your data, you are, of course, going to have some positive residuals and some negative residuals, right? Let me just draw a line here for you, right? Let me just draw a really bad line. Like, let's just say that I am so dumb that I thought that was my linear regression model. I honestly think that that blue line represents the data. Well, first off, I'd be an idiot. It doesn't represent the data. It doesn't really go through it, right? First off, all of the residuals are pretty large. Like, look how big this residual is. Look how big this residual is. Look how big this residual is. And then look at this one over here. It's going to go all the way down. So the residuals are really, really large. I don't want large residuals. I want a mix of large and small residuals, right? So having your residuals be mixed up, it's literally showing you that your linear model accurately goes through your data. And isn't that what we want? Isn't that what a good model should do? Go through our data. So again, a random pattern in your residual plots shows that your residuals are exactly what I've been trying to emphasize in this video. Positive, negative, big, small, completely random throughout the entire graph. Okay? So one big question that you will be asked at some point, whether it be on my test or the AP test, is a linear model appropriate? So now, if you've been paying attention over the last couple of videos, there are two things you can now say to confirm that a linear model is appropriate. Number one, the original scatter plot needs to look linear, right? Like, we've been talking about that for a long time now. If you see a giant curve in your data, don't put a line through it. So your original scatter plot should look somewhat linear. It doesn't have to be perfect, but it should look somewhat linear. And now, a second way to tell you that a linear model is appropriate is the residual plot should be random and show no pattern. Remember, this is a beautiful residual plot right here because it shows that my line is literally going through the data, creating positive and negative residuals in the beginning, positive and negative residuals in the middle, and positive and negative residuals at the end. Some are going to be big, some are going to be small. That's all a good thing that should happen when you are putting a line through linear data. I mean, come on, it should make a lot of sense. All right. So what does it mean if there is a pattern in your residual plot? All right, so let me explain this because what I'm trying to emphasize is that you should not see patterns in a residual plot. So what would happen if you did see a pattern in a residual plot? All right, well, let's take a look at this line right here. First and foremost, this scatter plot, I clearly see a curve. I mean, come on. If you don't look at this scatter plot and see a curve, you're nuts. There's a clear curve here. I would never think of putting a line through this data. But let's just play dumb for a second and thought, well, maybe I should put a line through this data, and it would look something like this. Now, come on. Clearly that red line is not a good model. It doesn't model the data. But maybe for a second I thought it did. But what I want to emphasize now is, what would the residuals look like? Well, first off, notice that in the very beginning, all the residuals are positive. So they're going to be like this, positive residuals. Then there's a huge chunk of nothing but negative residuals. All these residuals over here are negative. They start off kind of small, and then they actually slowly get bigger, and then they get small again. So that would be like a couple small residuals, and then a couple big residuals, and then back to a couple small residuals. And then at the very end, all the residuals are positive. All of my actual dots are above the line. And then again, it starts off kind of small and then they slowly get really big. So that would look something like this, small residuals and then big residuals. So notice the residual plot, and a very poorly drawn one, but the residual plot shows a pattern. I see this giant curve in my residual plot. So when you see a curve in your residual plot, that's a sign that your data had a curve in it in the first place. So this, what I'm trying to emphasize is that what you want to see in a residual plot is pure scatter. That's a good thing. That means that your line is going through your data. This scatter plot right here clearly has a curve to it. So putting a line through it, A, would be a dumb thing to do. I should not do that. I should have recognized from the very beginning that it was curved. But let's just say I didn't. The residual plot clearly is emphasizing the fact that there is a curve in the data because of this pattern, a pattern of all positive residuals, then all negative residuals, and then back to all positive. That's a pattern. I don't want to see a pattern. What I want to see is this, no pattern. That's a good residual plot because that means that my line is going through the data. All right, so let's really make sure you understand this, right? Like, I don't want this to be confusing at all. So if this is my scatter plot, I would clearly say, oh my goodness, that looks like a line. That looks linear. And I would definitely go ahead and think that putting a line through this data would be a very smart decision. Sorry, that was kind of a bad one. Actually, I'm going to go ahead and do that. That was a terrible line. But, you know, it would be smart to put a line through this data. In fact, here it is. All right, that's a line, right? That's good. Now, what would the residual plot look like here? Well, the residual plot would look exactly like I wanted to. Let me just draw a quick residual plot. First off, in the beginning, I have positive and negative residuals. Doot, 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 doot. In the middle, I got some positive and some negative residuals. Doot, 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 doot. At the end, I got some positive and some negative residuals. Doot, 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 doot. So again, the residual plot ends up looking like nothing. It looks completely random and shows no pattern, which is a good thing. That means that my line, my linear regression model, was a nice line that definitely represents my data. And that is the point of looking at residuals. All right. Whew. Residuals oftentimes are a little bit tricky. And I hope I'm doing a great job explaining this. So let's look at two examples here. Now, if you think you're done, you could go ahead and stop the video. But I'm going to look at two specific examples to really make sure you understand residual plots. All right. Researchers looked at the age in years of children and the reading levels of those children. Below is a residual plot of the residuals versus the age of the children. So this is not a scatter plot. This is a residual plot. And is a linear model appropriate? Well, I hope you're saying no. Look at the pattern. I clearly see a pattern here of a curve, right? That's a bad thing. That means that my original scatter plot probably had a curve in it because I go from all positive residuals and then it slowly goes to majority of negative residuals and then back to a majority of positive residuals. Now, I got a couple of weirdos kind of mixed in there, but if I see this, my original scatter plot's probably going to have a curve in it because that means that I'm going to have a bunch of positive residuals, then a bunch of negative residuals, and then back to a bunch of positive residuals. That's going to be a sign of a curve. And if you put a line through a curve, you get exactly the residual plot we're seeing here. Bunch of positives, then a whole bunch of negatives, then back to a bunch of positives. So again, if you see a residual plot and you notice a clear-cut pattern, that is a sign that you should not be using a linear model for your data. All right, one more example here. The weight in pounds of students' backpacks and the corresponding number of books in the backpack was recorded for each of 10 college kids. So I looked at 10 college kids and I said, all right, how many books are in that book bag and how much does it weigh? In a linear regression model, to predict the weight of a book bag based on the number of books in it is also below with the residual plot. So here is an equation that could be used to take X, to take the number of books in a book bag, X, and predict the weight of that book bag. All right, so this is the weight, that's the response variable, and the X variable is the number of books. Now, how do I know that the X is the number of books? Well, hopefully you just kind of understand that it's the books in the book bag that make it heavier or lighter, but you can also look right here on the X-axis to know it's the explanatory variable. All right, now this is a residual plot. And by the way, this is a beautiful residual plot because I don't see anything. It looks all scattered. Now that tells me that this model is very appropriate for my data. So what kind of questions can I ask you when I show you a scatter or when I show you a residual plot? Well, this is a pretty easy one, but one that's going to make you think. What is the actual weight of a backpack with 6 books in it? Okay, so remember, let's see here. What is the actual weight? Well, I don't know what the actual weight is. This is not a scatter plot, so I can't look it up. This is a residual plot. But here's what I can do. First and foremost, I could get the predicted weight because that is exactly what this equation is used for. It is used to take a number of books and predict a weight. So I'm going to grab my calculator. I'm going to do 10.53 plus 0.53 times 6. And the predicted weight is 13.71 pounds. All right, now, that's not what they asked for. They asked for the actual weight. Oh, but a residual plot shows residuals. So what I could do is I could look up 6 books, and I see a dot right here. And the residual value appears to be, well, I'm going to have to kind of eyeball this. Let's go with negative 1.5. So the residual value is negative 1.5. Now remember, how is a residual found? It is the actual weight minus the predicted weight, which I just found. So because I have a residual plot, I could look up the residual value. I don't know the actual value y, but I do know the predicted value because I had the equation. So now it's pretty easy algebra. All I got to do is take negative 1.5, add the 13.71, and the actual weight of the book bag was around 12.21 pounds. Now again, I did have to estimate what that residual was, so I can't be for certain, but I bet it's going to be pretty close. Somebody might say negative 1.4, negative 1.3. All those answers would probably be accepted as long as you're showing your work. So, a residual plot, we have already expressed enough in this video that it needs to look like nothing. That's a good thing. But what I'm now trying to teach you is you could actually use a residual plot to help you answer some questions. The equation is used to help you get predictions. The residual plot allows you to find what a residual value is for a given X. And then we can do a little bit of solving to help us find the actual weight. All right, guys, those are some of the questions that you're going to see from me dealing with residual plots. Hopefully you understand the concepts of residuals, and we'll be ready to work on some stuff in class.